lecture.
Yes, yes, put the recording on the cloud. Okay.
Yeah, yeah.
Okay, fine. Thank you.
So today we are going to focus on pandas. Last week we wanted to do some pandas, but we did not have time. This is a Python library, and pandas, as I already explained, is like, think of it like something for tabular data manipulation, like your Excel for data scientist programs. So we have Numpy, but this is purely for matrix kind of data structure. Numbers, do calculations, algebra, which we will also do the Numpy. So then we will focus later also on scikit learn, but scientific Python, SciPy. This is more of a numerical data, numerical basic routines, random number generation and data generation, but SciPy is for algorithms or numerical compilation. It's like a MATLAB. So we need this. We have been doing matplotlib. Matplotlib. This is for plottings, plots and analytics, visual. We already are beginning to use Jupyter Notebook, which is great. So today we are going to focus on pandas. So let me share my screen and go step by step. Anytime if you have a question, feel free to interrupt me and ask me questions. So what I'm going to do is share the screen that I want to, that we were working on last week. So let me.
Okay.
Yeah, go ahead, Saurabh.
Yeah. So regarding Panda, is there any dependency before starting Panda you need to complete Numpy?
Right. That is a good question. That is a very good question. So for dependencies, you may have to. Actually, there are not really dependencies for Python modules, most of them. So let me go back to this. So if you want to install a library, like in Pandas, so it may depend on, say, Numpy. I don't know if it depends on internally. So as long as you install through pip, say Pandas, P-A-N-D-S, you'll find this exact command. It might vary from operating system to operating system, or Python version. I would recommend pip3, or YouTube, how to install Pandas. It will install the dependencies, or even if it does not, it will show you what those dependencies are.
That is what package dependence. I'm talking about the functional dependency. Like people going through the Panda, you have to complete Numpy. So the understanding about the Panda will be clear.
Right. So they should kind of go together, but this I would say is more basic. Then we'll go to Numpy. Yeah. And both of them would be helpful for our SciPy understanding. But Pandas on its own is fairly independent. Of course, there are some techniques you have to know about the Python programming language, which you might not have been exposed, and that I will cover as I discuss Pandas step by step. That's why I will go step by step, so that you don't have to worry about the dependent knowledge. So let us go and share our screen here. So we were doing some Pandas before, although we did not put a label that it's called Pandas. And we will start from here. So first, you always have to borrow these Pandas. And we don't probably even need Numpy here. We can try and see that wherever it, but let's have this. Let's execute this. Shift Enter. Fine. So I don't care about this stuff here, and we will start from actually our Pandas here. I will make this separate later. Separate. Pandas, and this is a cell type. I change it to Markdown. There. Let's begin our journey with Pandas. So Pandas, I want to say is that I'm going to go step by step here. I have written some notes for you. Syntax. Okay, no, sorry. It gives a syntax error because I did not switch the cell type from the menu to Markdown. Okay, so it's a fast, flexible, expressive data structure. So, and it is suitable for relational type data that you can have like a worksheet in an Excel, and you have column names, and that's why it's a label and relational data. And it's supposed to be meant to work on actual software programs that you build as a data scientist. And this is where you can add value of processing large volumes of data. And also, and it's a very fundamental building block in Python. So if you tell someone, go to the industry, you know Pandas, this is a very valuable skill. It's built on top of Python. And it's suitable for many different kinds of data, SQL, tabular data, maybe they are ordered, maybe time series data, where you have a lot of marketing related data, sales, month over month, day over day, so on. Not only that, another thing, just like Excel has different data types on different columns. Maybe one column is only about a bunch of names or strings. Another column is about percentage. Another column is about numbers. Numpy can also represent it in the code like as data sets like that tabular. Essentially, it's suitable for most structured statistical data or data. And you can do a lot of data cleaning and make interesting queries. So that is. So now, so far so good. So is that all, basically? Is that all? No, that's not all. There is one other thing I want to tell you, that what kind of data sets do you have in Panda? I want to emphasize this very well. So there are two fundamental types of data sets. One is series, one-dimensional. So that could be a bunch of array of numbers. Think of it as like. And data frame, two-dimensional. That is like a table. So series data frame also, it's not do not confuse with an array. It is ordered like an array, but it has indices. Maybe every data point is related to a day or some time. That is very important. So now a few kind of practical useful things about Panda. So now what does it help us for? What category is it? So yeah, okay. So I can do this, okay. Yeah, so you can categorize like this. So series is always one-dimensional, and it is label, 1D label, just like I said that it could be for different days, dates, and so on. And data frame is the other one. So series and data frame. So we will use this term again and again. So data frame is for the Excel type tabular data. So now here are a few things I could collect and think of so that you can see the benefits of using Panda. If somebody asks you in an interview, why do you need Panda at all? I can do everything in Excel. I can do anything with basic Python. Yes, everything can be written in Python without even Pandas. But Pandas is a convenient library for manipulation of data, because you do not want to always go back to reinventing some libraries again and again in life. So first of all, it supports missing data. In regular programming language, you cannot have a element called nothing or not a number. It's either a number, it may be negative infinity, positive with a very small number, or a big number, but you cannot have something called NaN, not a number. So now you can take the table of Panda. I will give you an example. Let's look at this. No, maybe this is not the right one. I want to show you an actual Panda table. These are Panda table. Here is an example. TV, radio sales. So you can drop this. You can say that, hey, I don't care about sales column. You can drop it. You can delete it, or you can insert, or you can create new table, new columns out of these. Just like in Excel, you create new formula. You can do that in Pandas. And we'll get there. We'll have fun today with Pandas. By then, you will realize that you know a lot about how to manipulate large data sets. And then it can also represent higher dimensional columns, like tables that have, again, subclasses. And then data is very, it's intelligent way of subsetting the data, slicing, indexing. You can merge data sets. So then you can also reshape. Say maybe you may want to organize a set of numbers in a particular structure. You can do that. Hierarchically you can do. Then you can load the data from various ways. So you can load from SQL sort of probably libraries, or Excel, CSV, or HDF5 is a new format that is used for data, storing large data, volume of data. They essentially, it's like, think of it like it has its own structure inside, different data sets, their names, all the information packed together, and you can access programmatically. Plus, Pandas is very fast, and a lot of models depend on Pandas. A lot of libraries, like stats model is a Python kind of a, Python library. Oh, I mean to make it. Yeah, they use. And then it has been used for a lot of financial applications in actual real life system. So today it's a very valuable set of knowledge today we are going to do. So at the very least, what you need to, for these, you should import is called these two Pandas, right? So now I want to create the first data set ever. Give me a second. Give me a second. I am going to readjust my screen so that I can. Yeah. Okay. Great. Anil, can you see my screen clearly?
Yes. Can you please maximize that probably?
Okay. Right.
This seems to be minimized. Yeah, this fine then. Yeah. Okay.
Okay. Right. So you can see. Of course, a lot of these sites are not useful. This is just blank. Anyhow, so how do I create a Panda? Let's create with the first type. What is the first type? Series type. Can we do something with series? Okay. Here is I'm going to create a series. Yes, this is a variable. PD, which is the Pandas. Series has to be an array. 1, 3, 4, 5, 7. Very nice. We have a series, Panda series. Let's call it S, in fact. It's easier. And right away, print it. If you put this, you're printed. So the left one is called the index. These are the values. So it's an index. So now this says, they said data type. What is the data type? We'll visit it. What kind of data types exist here? And that will be useful for our kind of, the way you can inquire what data type it is that D types. So it's going to focus on D types. So it's integer, 64-bit integer. So what if I did 3.2? Oh, because you put 3.2, there is a decimal, it switched to float. And that is actually beauty of, in a way, Panda or Python. It can automatically assign the right type. What if I say, I have a number that's not really a number, but it's, so what you do is called, NumPy has something defined, something called NaN. NumPy, which is NP, .NaN. That's apparently that's not a number. That's also allowed in this kind of data sets. See, NaN. So NaN is a part of data. So now, how do you index it? Is it going to work like an array?
Just
Yes.
one instruction here, Kamal here. Yeah, so
Yeah,
this
Kamal?
is all are homogeneous objects, right?
Yes, all
They
are
should be
homogeneous in a series, but
Yeah.
this is really kind of made homogeneous because in regular programming language, not a number is not considered a number, right? But yes, it's a
No, if I say,
homogeneous.
if I put a string there, then it will throw some error, right? One more element if I
Oh,
erase this.
let's see. Can it handle that? Let's see. Let's see if it accepts you. I am putting your, if I am treating it like a string.
It will reject me, I think. No.
No. Now what happened is that it started treating everything like an object.
Okay, got you. Clarified. Thank you.
Yeah, it switched the data type. That's interesting, you see. And let's see, can you do, 0 plus something here? Because you put addition, it did understand. 0, 1, 2, 3, 4. Let's see. Now you do not support addition operation between an integer and a string.
That's quite obvious. Yeah,
That is controlling that. Okay. So that is a series data. And now, is that enough? Like, what if I want to know about like a whole set of I want to create something for the whole year. Let's create the dates or real life date. It's a series. Yeah. Go ahead, Nimisha. You had a question?
Yes. I just had a simple doubt. It's like in Python, the plus operator is considered as concatenation operator, right?
Yes, it is.
That won't be applicable.
So in Python, okay, let's see about it. That's interesting question. While we are, this is important for any programming language. So let's say 2, 3, 4, b equal to 2. So now a plus b, we know what it is. Great. That is a concatenation, that's an addition operator. If they were an array, how would they behave? And that will be concatenation, right? So you see, it is depending on the data type, Python can determine what operators apply. And these are already kind of defined. But if you do something completely that does not make intuitively any sense, then you will be in trouble. Here is one example I'm going to give you. For example, I do an array. It failed, see? Because it does not have the definition of adding a string to an array. It has no meaning. However,
but a number, if you replace the array with a number,
oh yeah, then also it will fail because you are trying to add an array with a string. It has no meaning, you see. Here it is what it says, integer and string. It does not go together.
okay.
But let me do something interesting. Okay, let me show you something before that. So when you have a string, suppose in Python, and you want to create a list out of it, say b is hello, right? A is hello. Great. It is hello. I can show you, prove it to you, hello. But I really need to put individual characters in an array. So then there is this thing, command called list. You can do, not command, function. It's a part of the Python system, you see, it created an array out of it. So now let's go back and see here what happens if I make here, this fails. Oh, this is, okay, that's a syntax error. Not a, so this fails. String to list, I cannot add. Let's put list here. And because they are both lists, it should do list concatenation. See? List adds to that. So your question, as you said, that is it going to concatenate? Yes, it depends on the data type. Python treats it like that. Okay. So now let us go to adding a set
I
of.
have a question.
Sure.
Yeah,
Bashapika.
in the markup cell above, it's written that series is a combination of homogeneous typed data. If you go above,
Yes.
yeah, but here even string is there and it's accepting it, right? So above it's written 1D labeled homogeneously typed array.
Right. Yes. As a data set, you are able to take it, create it. When you do say, but not the operations will not be supported when you do certain operations. Say, for example, if you do keep them homogeneous, then all the operations that are defined will work fine. But this, we have essentially abused it. There is no guarantee that it will work. For example, I don't know if you have seen it. Say, for example, you are writing a software program, C program, say, and you forgot to initialize the variable. And by default, you see that in one compiler, it's always 0 if it's an integer, if you do not initialize. But if you actually, in another compiler, you may see that it essentially is not 0. It should be 0. You feel like that. But it may not be 0 because it is not a part, it may not be a part of the language specification that, hey, you do an unspecified variable and I will always make it 0 for you because it is the right thing to do. This is, you are in that luck here. You are in that luck. There are a lot of operations where, because I have mixed them up, it will fail actually. Yeah, I don't know. Okay, Kashyapi, did it explain?
Yeah, okay.
Yeah, so always be careful with these, that it has to be well defined. It can automatically switch types, but not when it is incompatible. It will fail you sometimes. Okay, so what about dates? As you know that in Excel, you always need one thing. Date is a fundamental type. In fact, there is a separate type called date because that's what real data needs. Can I create a date range starting from 2019? I don't know, today is June, it's 0601 for the next 5 days. You always need series of dates sometimes. There you go. June 6th, June 2nd, 3rd, and so on. You need, this is how you create series with pandas. So these series are important. For example, you may have an index, you may have date. Yeah. Go ahead. Okay. So so this is the kind of showing that you can create a set of dates, but you have to use it somewhere. It's not enough to just have a set of dates. So here is what I'm going to do. First, I'm going to create for you an Excel, a table or Excel worksheet looking thing, table, let's call it. And I will have 4 columns and I will have 15 days there. And then I'm going to have a random number in each cell. Okay, so here is what I'm going to do. First, how do I create random number again? You might not know, you might have forgotten or have not seen. Numpy has a library. So this is why Numpy is important, because it's a very straightforward library for generating data, random numbers, but not for it does not have any sophisticated algorithms, but straightforward data, like random. There is a library called random, Numpy, and I want to create a random number, and several of them. Let's create 3 of them. This is important. Take this as also that we are beginning to use Numpy as well. You will be using Numpy more, because that's the next topic we will discuss thoroughly. So see, I got random numbers.
Okay, sure.
Yeah. So, and usually there is a range, and you can set the range. And this is what I showed you, that I can do, created this random number, 3 random numbers, or I can do 5 of them, you see. So all of them are between usually 0 and 1, or -1 to 1, depending on what, like you want to do. Let's see. So another question is that this random n is essentially a for normal. It's a normal distribution. I remember at one point I was explaining, but normal distribution gives you number between anything from -infinity to +infinity. So it's a Gaussian distribution or something. Right? So you can also have uniform distribution. Let's see if it has uniform distribution. Integer also you can have. So this is simply one integer between 0 and 5. So, but let's stick with one random number generation in normal distribution. We don't care. We just need 5 of them. We are not going to do any calculation on it for now. So from the normal distribution, I got 5 numbers. And I want to put it in a table. And I promised you that we want to put in this format. There will be 15 days we have. For each 15 days, we'll have 4 columns, A, B, C, and D. And that's how we want it. So how do we do that now? So first, I have the dates here, and I'm going to use them. So first, let's create a data frame. So far, we have been dealing with series. Now it's time to go to data frame. df equal to PD. It's the Pandas library right here. It's a short form for PD. Data frame. Now I want to have all these numbers here. I will have to have first let's generate a bunch of numbers that suits us. How many numbers do I want? If I have 15 rows and 4 columns, so 60 numbers I need. I'll need these numbers. But the problem is that I'm going to organize it in the form of a table, right? So I have 15 rows, 4 columns. So I need 4 tuples for each row. Instead of that, here is my shortcut, see? 15 by 4. This random number normal distribution, n is for normal distribution or Gaussian, okay? They have written the function that's suitable for this kind of tabular data. What did you get? You got the same, you got 60 numbers, but this time 15 rows and each row has 4 columns. This is going to be useful to us. Let's store them in data, a variable called data. Great. Now let's create our data frame now. Data frame is a variable in Pandas. I'm instantiating here. So data you have to have. Well, what about the index? Index is the numbers on the side. Like here, these are index on the left side, 0, 1, 2, 3. And index do not have to be always numeric. It can be date or other forms. So index, I'm going to say what are my indexes? Dates that I have stored in this variable dates. Dates. Great. So then what happened? What about columns? Columns, I'm going to use A, B, C, D. It's an array. What am I going to get? Let's print it out. Oh no, date is not defined. I guess this is data I meant. Data. This is the one. Dates are defined, yeah. Great. Here you have these different days. This is the index. That's why it does not have a name, you see. And this is the value you got. Let's make sure that I'm going to regenerate again, so it will be a different set of data. But remember this. This is minus 0.6095, and this is 1.52. So that's what we would expect here. So let's insert that here. Here you see, this is over here with some numerical precision thing. This is here. Similarly, this is the last row minus this. So I have shown you a table that I have created, Pandas data frame rather. That's the right terminology. And that has these ABCs. Oh no, this is typo. Yes. We should have distinct names. So that's where we got. So now I showed you a trick where I call it list here. Let's try to use it in a smart way. It's an array anyway. So this is to get you used to Python programming. So I can call it ABCD, ABC. It will anyway create a list. See, I'm using this list function right here. It's the same thing exact. There's nothing different about it. And then now we will see, if we want to see only the first few columns, rows for a large data set, you cannot just view everything. It's by default, I think 5. That's what I showed you, the 5. That's what I wanted to show you now. So far, any questions so far before we move on to the next advanced level of this?
Yeah, one quick thing. See, I was a little shocked when you gave A, B, C, and D as the column name. So we can have same names. It's not a problem, right?
You can have the same name, but
I was expecting it will throw an error.
right. I think it's the people, those who use the library. Yeah, they should, I think, should give an error, I think, to be, if they really support or not, I don't know, but I don't think they should, because it's going to be it will create ambiguity, right?
Yes, right.
There is the reason for ambiguity. Let's put the error again. Let's do some experiment here. I'm going to create again.
When you created first time, I thought it will throw an error, but it didn't.
Yeah. So the way to access a column is like this: d dot say A. Great, right?
Okay. Now
what happens if I do C?
Yes.
I would say it's the first column will come. The first C. I mean this third one.
Okay.
I feel it. But you know what? Even
it display everything.
It gave So it gave all the C's apparently.
Okay.
But I would highly recommend not to do this at all in your actual program.
Yeah, exactly. I agree with you. And head by default, like in this we have 10, top 10. So here it is 5.
Yes.
Okay.
Yeah. Here by default, yes, absolutely. No. Here it is showing all 15. If you do head, it's by default the 5.
5.
Yeah. 5 rows.
Yeah, sure.
So that's the So now let's go and create something more funny data frame. Life is not all that simple. Sometimes data sets are very complicated. So I want to create a data set in all different crazy ways and somehow expect it, right? So my goal is to create a data set where some columns will have the same x, 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 x or y, y, y for some reason. And I don't want to go on specifying everything from scratch, something that happens, make an array out of it. I want to make my life easier and want it to be a little bit smart. Guess, just like when you did the add operation, it was able to guess, well, can I, if it is of array type, then I can concatenate. If it is of integer, then I can add, regular numerical add. If it is a string, which we did not do, by the way, we should do that just to show you this point. What happens to this? This is it, but there is something to be said here. Maybe I could have an array. Sometimes in Python you will see this problem. No, not problem, convenience rather. Python has a built-in function called join. I don't know if you have seen it, but you should see this. So this is an array, put it in an array. So then what you need to do is you want to concatenate all of them, right? So because it's an array, so you can use a function called join actually and put an array. So it added this. So you don't necessarily need this. Now that got stuck, but I want some space. This is the intermediate. It joins with something, it's a string, but it puts in between every two elements. So say this is a string, right? This is how it's a very convenient function. And if you want tably limited, this should be tab. It doesn't print it here. Maybe it should. It will print actually if I do print. Because you cannot see it now. It's printing. So that's how it, or any string you want to put. So use this sometime. Or if you want to print it the right way that we can read, space. Just wanted to let you know. So you see there are a lot of conveniences in Python. So if I want to create a data frame and only one column has the same number, what is the point in me trying to specify everything, same thing like 15 times? It's complete waste of time. Or create a data that, I will put the first day, and if there are 15 rows, the date should keep incrementing it. You have seen probably in Excel, when you pull it and drag it automatically in gradients. Well, Pandas can do something in the programmatic sense. Let's do that. df2, just a variable name, Pandas. I want a data frame. Great, data frame. What do I want here? I will create, you can specify like that, column by column. A should be 1.0, very nice. Then I want G NP A arrange 5. Before that, let's see what we are doing here. What is NP A range is about? NP A range. So this gives you a range array of numbers, NumPy. 0, 1, 2, 3, 4. That's what it gives. So you see, this is an array. This is a NumPy object. This is just a number, and I want a data frame. It's odd, right? And this is supposed to be a column of 5, and this has nothing. I wonder how it would look. Let's look at it. So first of all, it gave an error because it did not accept data frame. Why did it not accept? Well, this is not even an argument. This is a comma, colon. What am I trying to do? Well, in Python, everything is things should be dictionary, right? Dictionary is represented like this. These are keys and these are values. I know that. Let me explain to you, first of all, again. These are very tricky things we should be. And once you know this, You'll be very good at it and it will be no problem. You'll always know what to do. Let's see, how does it look like? Let's print here. You see, what did I get? I have a key called A. It has value 1. G column has G key has 0, 1, 2, 3, 4. What is that supposed to mean? So I'm going to enter, create a data set. So this needed 5. It is another thing if I had like, oh, by the way, another trick you should know. I'm going to put them all together, but it's very important for you to know these little tricks. If I have a number here, 1 times 4 I multiply, you get 4, right? When you do this, let's see what happens. You get the same thing. What happens if I have an array and multiply by 4? You see, it keeps repeating itself, the array. This is a Python syntax. That's how it keeps repeating, flattens it out. Okay, so here is my story. I am essentially, if I create like this one, this makes sense, right? I have 2 columns. I will have 2 columns in my data frame, and 0, 1, 2, 3, 4, 5 rows. This is how it should be. So let me put that inside. So you see this A begins from parenthesis to parenthesis. Here I'm creating essentially on the fly. Here is the same thing, except here I have to make this correction. And let's see what we get. Okay, we did not get something. It's because I forgot the 5. Looks good. It's exactly what we meant. But what if I just say 1? That is ridiculous. This is not going to happen. It also is the same thing. Why? It could guess that, well, this has 5. This has 1 number. Probably it is a convenience of just a 3 all the way. It's a constant in every row. It's a convenience. But let me try another one. Array, but not exactly 5, length 5. This fails because it cannot infer anything. What am I supposed to do? At least here you could say, oh, you are talking about a, this also doesn't understand. It's an array of 1 element. This I understand. Well, it means you mean a constant, right? Yes, that's what it is. Now, this is what, the idea about this. And this constant can work for even dates. So I can say B, I can put our date, a pandas date. How do you write the pandas date? Let us see how we are used to. Oh, this is just a date. This is a date range. This is a function, but we want to create a date actually, timestamp date. How do you convert? Like how you typecast it. So this is how you do. PD, panda, (2019), say June 1st, I don't know, 06, comma. Oh, it's the same date. That is nice. And now you say that I want it to increase BC, B1, let's call it, another one, B1. I want the date to increase actually, not like this. And then we can use your date range technique we were using, right? Initially. I think we were doing it here, right? Here, like copy, yeah, pandas data range. But it cannot be 15, then it will be problematic. We need for 5. Because otherwise it will be 15. 5. Great, that's B1. There you go. You see, this is a constant. That's why you gave only 1 element. And this is an array series you created on the fly, like before. And you created B. So then, can we do something more here? How do we create a series of, like I say, I don't know, float, like numbers? You can even insert a Panda series. See, these are, what is this? This is one number. I'm sorry. This is one number. This is one date. This is a series of dates. And this is an array, NumPy array of 0 to 4. You see, this may have the shape of an array, but it's not the same as this. This is an Pandas series of dates, different object. This is a NumPy array. It's coming from NumPy. So you see, NumPy, Pandas, they are very useful to go together. Then I'm going to add another variable, a string. Foo, I got it. Nice. That means I can get, what about, also, I'm going to create another one. Let me see how to make it more readable. This is becoming ugly.
Hi, Kishore.
Yes, go ahead.
Yeah, so NumPy is based on array, right? And we also have a list which is similar to array in Python, code Python. So how these two are different?
Oh, so in most of these Python objects, when you say have an array, so NumPy array is essentially, it stores an array, but it also has additional functions. So it is wrapped around. The core values are array. I'll show you what it is. Okay, give me a second. I will show you. Just format this and I'll show you the difference. Okay. Sorry. Let's create two arrays, right? Two arrays. Array A is equal to NP and B is equal to, say, I'm just printing two array. Observe this. Okay, maybe I should know. It always prints the last one, so let me print this side by side. Okay. You see, there are two different things. NumPy array is A. It's an array. Let me also make it exactly same. 1, 2, 3, 4. Somewhere I must have missed up. Okay, here there is a comma missing. This is an array of numbers in Python. This is a NumPy array. What is the difference? They look same, except it's an array object. So what? Let's do something here. A tells you it's an array of shape 5. NumPy tells you. Let's see what B will say. Doesn't even understand it. What is shape? So essentially, just like it's like in Java boxing, it boxes an object, but it has a lot of layers on top of it. NumPy is not just the original array you are seeing here. Yes, it is a part of it, but there are more functionalities that are not visible, that you can call. But in a native Python array, you do not have those functionality, and so you have to write on top of it. So semantically, yes, they both hold an array. It's like you have some food, and one thing, take it, eat it however you want. Another one is like they are serving you in a nice plate, but it's the same food. That kind of analogy. Did it explain your question or resolve your question, Saurabh?
So we can infer that this NumPy has a base class list.
Yes, you can assume that in the base class, of course, at the base class, it will be Python object, which is the base class, but it adds a layer and a lot of functionalities, methods into it, and stores the original array inside it.
Okay.
So that you can ask different, attributes, questions, operations on the internal array. Like the shape, you see, shape is an attribute, it stores it. And it's 5 comma, that means it's an array of length 5. It's not a primitive data type, Python. Yeah.
Okay, and there is any difference between the execution speed or something between these two?
Yes, of course. Probably if the NumPy guys did a good job, it will be slightly slower. It is essentially when you have a primitive type like the second array, it will always be faster. It doesn't matter how sophisticated you are. If you do layering, it will always be slower. Maybe it will be very little. A classic example is, as you know, long time ago, C used to directly compile into assembly code and it would run fast. Oh no, machine code. It would run fast. Java would run on JVM, which is bytecode interpreted. And so C was many times, C++ was many times faster than Java because Java was running on a JVM. Today, if you look at it, C++ and Java, they run almost comparable speed because those who implemented JVM, they improved their internal execution, they optimized it. So this is similar concept. So anytime you do layering, it will always be slower, but it's a matter of if you design the library well, you can decrease that gap.
Okay.
Yeah.
Thank you.
You're welcome. Yeah. So now, what does our fancy frame has? We have B1. I've shown you one constant. Okay, is that all? Well, what about other NumPy crazy thing? B. Say I'm going to add another NumPy array. I'm going to create a NumPy array out of another array, a constant, 3 times 5. As you all know what I should expect here. What do you expect here? 3 times, array times 5, say. It's a 5 trees, that's all. So I'm just creating a straight up NumPy array. Without NumPy array also will be fine, but I'm creating it. B, a bunch of 5, see? Oh, did we get 5 or not? Oh, we didn't get anything. A, B, C, D, oh, trees, yes, D. 5 trees, that's what I got. So now, so far so good. Is that all I can get? No, you can do better than that. You can have categorical data, which is essentially, it could be number, strings. You can have your recal. Categorical is like, tall, very tall. These are anything that categorizes it. Medium, somewhat tall. Yeah, I put it in an array and these are my categories and exactly 5 of them. It has to match. And I put it in the column E. Right. Okay, somewhere it failed. Let's find out where it failed. Here. So automatically it adds if I open it. Yeah. There you go. And let's have one more column. You can have complicate, approval. Rating, say. You can say approval rating 1, 2. If we get to doing say recommendation systems, I don't know. Approval rating, say it can have this. These are straight up arrays, but I can make it categorical as well for NumPy. So we have shown how to create a data set. The most interesting thing, I think, you can deal with nice time range. You can create times which you need. I'm just trying to draw an analogy from Python. What we need. Constants are useful. String constants are useful. Numeric constants are useful. You can extend an array, it's useful. You can put categorical things, useful. This is great. And now you can do even your df2. This I'm not sure. Okay, great. This is tree. I don't know how to index the approval rating if it is DF. There are other ways, I'll show you, but this becomes, so this is how you do. And when you access a row, what happens? How do you access a row? Tree, will it give me the third column? Well, because the F1 is not defined. Well, it does not show me anything. Key error is tree, it does not give me any number. I was hoping to get maybe the third column. How do I do that? Okay, so that means there are other ways of accessing that, which I will come to shortly. Okay, so this is how do I access these values for the third row. You see, third row, 3.24, medium, all this. That's something will come, but that's what I wanted to give you an idea about. Any questions so far?
Kishori, regarding this categorical data, that we can use simple array also. Is there some functionalities that we can perform on this? I mean, the categorical data type.
By definition, in categorical data, you cannot do too many operations because they are not numbers and they are limited. They are essentially labels. Yeah, there are not too many of them.
No,
So
I
we can
think
just take it as an array, right? If we want, I mean, do we have to keep it as categorical or?
You don't have to, but in some libraries, it's useful because Pandas is a library for data types, and there are other machine learning libraries. We will show how to use one. You will see that they expect the categories like a Pandas categorical data. So then you say, this is the category and classify this. Say, for example, you are analyzing data, coming up with a machine learning or data science technique for spam filtering. And there are two kinds of category here, spam or not spam. So in that case, if you use some libraries, they will expect you to send the categorical data in that format. And you have to create a Pandas object called, these are my category, and this is my data, then it will work. But as far as concept, yes, categories are just labels, and you could use strings as well. But then you have to reinvent the whole thing yourself. You'll have to rebuild your own library to understand your way of doing it. But yeah, otherwise there is no, concept-wise they are the same as you said. Any other question? Kashyapi, you had another question?
No, the same thing actually. Categorical, without the categorical, if you take simple array also, it would have worked here, right?
In this case, it would work, yes.
Yeah.
Yeah.
Okay.
So let's see. What have we done? D type.
Like links and images.
Could you say that again?
I just wanted, I'm not sure, just wanted to ask, does this support different things like images and links, these kind of things in this data?
Images. Images, it will not. For image, you will have to use Numpy sort of thing because those are matrices. You can, but it will not be a good use of your Pandas. It's like storing an image, not as a blob, because an image is essentially, let me just, because we will be doing image at some point, and I'll just give a 1-minute introduction to that. So there are a few types of data sets you will continue using it, right? Image is one of them. And Python has a beautiful library. I can load an image and print it on the Jupyter, play it with it, transform it. So image usually is an array. You can look at it as a matrix, and this is what your size is, say. When if you look at your image, you will give you a dimension, right? So 750, maybe 750, those are the pixels, 750 of them. and you can index each of them, right? This may be 300, say. This is 250. So that means essentially against 250 and 300, in that index, you have a value. Let's say it's a black and white image or TIFF image, right? These images. They have one value, and that value is between 0 and 255. That's the convention. This means absolutely white. This means dark. So this is the range. So essentially, if you have an image, you essentially have a matrix of this size. So if you make these many columns, 750 columns, and give artificial name and rows, it is not a good use of your Panda, because Panda is not designed for, just like Excel is not designed for image processing. You can do it, but it will be slow. But you should use Numpy, because that is directly suitable for manipulating arrays. And that's why we will do Numpy later in the next class, that you can actually do a lot of algebraic operation, matrix operation on Numpy faster. Did it explain, Nimisha?
Yes, thank you.
All right, so let me again share my screen. Here we are. Right, great. So next, right, so I wanted to show you the deep data types, what it is, right? Here you see the data types. So in the data frame, there is this attribute. It tells you what type of columns are each individual, what type of data each individual columns contains. Column A has float 64, or rightly so. Then approval rating is integer, I thought, right? It is. And this is date time, 64, right? And this is integer, this is category. This is just an object. I guess it doesn't know how to deal with F. What is it, F? It's just a string object. G is a number, integer. So this is how it tells you the column types. And then, of course, there is another thing I want to show you. df2, as you by now you know, head means first 5. You can do df2 tail as well. It's the bottom ones, last few maybe. Is that true? Oh, that's because we already had 5 only. So let's say tail last 2. So that shows the last 2. Okay. So that is what it is giving you. Now, as I told you, this is the index, right? This is the left side without any column. So you want to find out the index. Great. Range index 0 to 5 and steps of 1. That's how it expressed itself. It's essentially 0, 1, 2, 3, 4. That's why the same thing actually index means. And actually another thing is that you can also ask, what are the column names? df2 columns, I think. You see? By the way, you would see these U sometimes. This means these are Unicode. It supports Unicode. That means it can handle symbols beside these ABCD English. It can go to even Telugu symbols. Of course, you have to install the font, but just to give you an idea. So then another thing is to summarize that table, describe. Okay. So these numbers, approval rating A is a number, you see, all the numbers are same. Standard deviation is 0, just to recall. And it gave you summary of only those columns that are numeric type. See, there is nothing to give summary of these. So of course, it will examine, is it a float? Yes. Integer? Yes. Probably not. Not. Yes, I can give. Yes. So that's why you have A, approval rating, D, and G. A, approval rating, D, and G. Because these are the ones that these describe basic things can be computed on. So that is so great. But can you transpose it? Sometimes in Excel, you need to transpose it. Also in numerical T, it transposes the data. Look at it, what happened to that. Approval rating came, it made the columns rows, rows, columns. It has the same data though. This is for transforming. Then you might say, I want to know, because you have made this an index can be accessed as with a, can I index, one means what? So one means first one, 0 means the first one, it will be the second one. Of course, everything starts from 0. So you see this is the first number when you do transpose. So A, B, approval rating. So it's just showing the first tail, let me see, tall, foo, 0. Yes. So what happens if I remove that? Then it cannot do 0 axis. You may have to change axis. But anyhow, so this is something we will be playing around. So I'm thinking, so let's see. Yeah. So next I want to get into index and sorting and other stuff. Before that, before we will take a 10-minute break shortly, but before that I want to show you a few more things. Transpose, and I care about from index 2 to 5, say, columns 2 to 5, 2, 3, 4 actually. You see here, these are the ones I found. 0, 1, 2, 3, 4. So these are the ones it got me. So next we will do more sorting and stuff, index, accessing, ascending, descending number. So why don't we take a 10-minute break here and I will resume. But before we leave, do we have any questions?
I have one question.
Sure.
Yeah, here we just like we have for data frame we have describe and transpose. So I didn't understand one thing, like for describe we have used it as a function, right? Dot describe and brackets. But for transpose it's just data frame df2 dot t.
That is a good question actually. Yes, that is a good question. Yeah. Let us now use the board. So when you have a data object, say array, right? Say 1, 2, 3, 4, 5. There are several properties here, right? What is it here? What type it is? Type it is. How long it is? And what is the average? And what is the minimum? Or what is the standard deviation? Think about it. If somebody asks you, what is this data type? You will say, well, say integer 64. There is no computation required. I already know it's a part of my data information or metadata. So I'll tell you how long it is. I don't need to think about it for. Average, I have to compute. This length, or we call it shape also. Minimum, I may have to compute. In some cases, it's a gray area. Standard deviation, I have to compute. Compute, right? Think about it yourself as a person who developed library. There is not much any computation to do. It's not like I'm going to start counting how many are there. It's already a part of the data type. So these will require, say, if this object is of type, say this is NumPy object, suppose, this will be like dot shape because it's an attribute. It's a variable that stores the value. It knows. Here, describe needs computing this, computing that. That's where you have this kind of computation. Whatever function you call it describe, you have to call a function. You have to compute. That's right. Essentially, you are calling a function. And this data is ready-made. There is not much to compute. It's a part of the attribute. Did it explain, Kashyapi?
Yeah, I got it. Thank you.
Okay, yeah. So why don't we take a 10-minute break, and then we'll, unless you have any question, then we can answer it. Yeah, Saurabh, go ahead.
Yep. Regarding this describe, again the same thing. So we have noticed that for this date and this tall and short this categorical data, right? There is no data populated if we call describe. So even though like maybe it cannot understand what is this as of now, but is it always constant, or if we have more sample data based on that category, it can determine at that time?
My guess is that Pandas, when you do describe, essentially this is how I would implement describe if I was the Panda developer. This is just to show you, not that. So it will be the Pandas data frame class, right? Class data frame. Data frame, and it will inherit from object, whatever, Python object. Then I will have one def function like I explained last time, init. Right? I feed the data. That's how you create the object, right? When we created the data sets, you have remember that I do PD data frame. Then I put the data array itself, and then some other things. This shows that it is in a part of the Panda library. This means that there is a class somewhere in that library. The fact that you can use this parenthesis like this with a data, that means in that class there is a function called dash dash init, and it should be of this signature self. I told you last time that it's reference to itself like this, and data equal to, there will be data. These are named arguments, these are called data, so that you can hear data equal to. I think data is not named, so you don't have to do it. It expects a data. It cannot exist. And some other default like index and all will be default. By default, it will none, it will prepare itself. So this is when you have the data, it will have an internal data called self.data and store this data incoming into this, say, and blah, 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 other things. Now, it will also have a function called describe. Describe self. Great. So what will it do? It is going to go through for each. I'm sure if it has data, it will also have a self, I don't know, index or something, or D types, right? D types. It will have all the data types. From this, if you or it will infer it, compute from it, say it's integer, 64, if it is float, whatever, it's categorical. So then what it will do is that for it will look through all of them. For each index, it will say for each index is self D type. This is an array, and the first one corresponds to the first column. Second one corresponds to the second column. D type, right? I'm looping through it. Then if X is one of them, if X is of type, if X is of type, Python type, suppose, is in say int 64 or float 64, so on. Whatever, if it is, then it will compute, minimum. It will compute. I'll not write exact syntax. I'll say it will return all these things: minimum, average, max, and it will essentially do from a compute stats. This is an internal function, and it will use the data self. So when you call describe, it will look at the data types, and if it is of data type integer, float, if it is in this. If it is not one of them, then it won't do anything. And it will compute this and it will report to them, print it or give it to them, print them. Then it will print mean, average, and so on. This should be some kind of a implementation, I'm just saying. So Saurabh, did it answer how probably they might have implemented it?
Yeah. So that is fine, that I understood. But I have just one doubt. Like, as currently we have only one sample point, right? Tall, very tall, short, for just a small set of data. So if the over period of time we have a huge set of sample file, so the situation will be the same, or at that time it may calculate the mean, standard deviation, or count as well.
If you change the data, it will again compute. That's why it computes. So if you have updated the data set, it will compute a new one because it's a function. It will recompute all.
Okay, because right now it's not displaying its count, mean, standard deviation, right? So if our data sample is increasing at that time, there is a chance it will display the count, mean, and standard deviation.
Yes, it will display the new standard deviation and all. Yes, it will adjust to itself.
Yeah, that is the question actually. Okay,
yeah.
Thank you.
Also, you may have to, suppose you want the categorical data to show that. So then you have to switch the categorical data into numerical data so that it shows up.
So we need to put a mapping there. So that will.
You need to do the mapping, and I will show you how to, in fact, convert it on the data frame, which we will do after the break. How to transform, how to delete a row, how to delete a column, how to add a column, all these things. There's a lot more. So Panda is a huge skill. If you are looking for data science jobs, Panda alone will take you a long way without even knowing any machine learning. This tool is huge. Yeah. Any other question before we? Okay. So we will then meet in another 10 minutes. Are you there? Neil, can you hear me? Kamal, can you hear me?
Kishore, we can hear you.
Okay, great.
Yes, we can hear you clear.
Okay, so we can start then. So let's continue with our great. So far, we have learned how to create a data frame. Now let's learn how to transpose it, how to sort it, and so on. So let us do a trick here. Suppose I want to do an index sort. So data frame 2, again, head is this. So can we sort it now? Let's say df2 sort index. What do I mean by sort index? What am I trying to do here? So sort index, let's see. What did it show me? It seems like it has sorted it by the index, first index, 0, 1, 2, 3, 4. Maybe let's say there is a choice you can give, ascending or descending. True. Nothing changed. Let's make it false. So sort index is essentially you are sorting by the index. It could be a name, number, whatever, or the dates even. So you can sort it by ascending or descending in this format. So there is this concept of axis. So you can sort also according to these columns actually, or rows. So if you put here axis, these are, you see, ascending false, that means descending, the highest will come, so it has sorted it, all the columns. Nothing has changed except the columns were swapped here. So that is called the axis. If you want to swap by columns, axis is 1, otherwise by default it's 0, it's by row. Any questions on that? This could be confusing. So this is essentially you are able to organize the rows or columns.
What is this? Sorry, I didn't understand the axis thing. Can you just repeat it, please?
Yeah. So essentially, somebody tells you this is a table, either shuffle the rows in a particular order or swap the columns. Right, the first column, you can change the columns. The meaning is the same, right, as long as you have the same column name. So let's start with that. And let's say we are always going to have ascending. So in this case, what happened? By default, axis is 0. So that means it looked at the index, it says, oh, 4, it's descending. So that means the largest should be first, and then it should continue decreasing. So it will pull the first row here. Look at this row. Now this row appears here first. Second row is third, 3 is the value of the index. Now it shows up here, which is third. So it has reversed it. But now let's say we want to do, and that's called axis equal to 0. By default, axis is 0 when you do not give. I can give it. The same thing. Now I'm saying that I would love this G to come to the first. This last column, I want it to show up in the first. The next one. So you can sort them by this name of these columns as well. So that's the axis that's axis 1.
Yeah, no. Just one quick query here. So are we sorting with based on what column? Like I'm not able to understand that.
Here, index. You see sort index.
Oh, okay. Based on the index number, we are sorting it. Okay.
Yes. Yeah. We will sort based on value and stuff as well. Yes. So now let's see based on column index now, or columns. You see, G has come to the first, then F, approval rating, and this alphabetical lowest. So essentially, you are able to sort this column table like this. So now, this way you can switch, try different combinations. What if I want both? What if I want sort this first and followed by the other one? Maybe we can do that. Axis is 0. We know what it means. This we have seen. Maybe we can do more. Maybe again do sort index. Maybe. Ascending, false. So first it sorts that way and then again sort by. Can it do that? Well, looks like you could. You can nest these things. You see, here up to this point, when you do sort index, you got something. Then whatever you got, that is also a data frame, right? Let me type it out here. Let me put a comment here and say, if you do this, you get the original. Now you might ask, sure, I see something on my eyes. After you sort the whole thing, what happens? I know up to this, it's a data frame. After I sort, what happens to it? Well, it is again a data frame. Really? Let's check. You can do all this sort index on it only on data frame, not on others. Well, that's what it says. Panda core frame data frame. It is, so you can do that. You can again do sort. Because it is itself a pandas frame, then I can do these things. I can get it. Well, I can do revert it back also, according to the first one. I can again call it sort. It will keep calling one after another, cascading. Let me know if you have any questions. So this is about sorting by rows or index or columns. What about you want to sort by values? This is by only, you are only switching around these columns and rows. What about if you want to sort it not by index but by value? Let's say column E. So there you have to call it df to sort values. Well, whose value? You have to tell it. Well, by equal to, let's say one value. I call it, I want to sort it by E, say, if that's okay. So that means I would expect sort the values and it will be by default ascending. Probably M will be the top, then it will be S, then it will be tail, a medium short tail, then it will be somewhat tall, then at the end very. Let's see. Yeah, what it did, of course, here I did not apply this, but I could have this too, not a problem. I could do that too. I just sort it, keep the same shape, keep cascading it. You see, medium, alphabetic. I can do reverse it. I can reverse it for you. See, very tall. So, any questions on that? That was interesting. You might want to do something more than that. Is that all you want to do? What about sort it by E, then sort it by, first sort it by E, then please sort it by approval rating. Then you can do like this. Put it in an array. I see. So sort it by E, then by approval rating. You see, first I did sort by this. Then if two approval ratings, then among the approval ratings, in this case, it would not make a difference because everything is different here. So in order to show you the difference, I have to do something more here. I have to switch the categorical or add some additional row into it. But you can switch by one after another actually. So I think I would like to have a data set that has all of these data sets quite different. Let's see that other data set we had, that you can see the values more clearly. Oh no, I don't see. Yeah, green. Okay, so here maybe I can make it tall, 2 talls. Recalculate it. So I have 2 talls here. I'm again have to execute the cells. There is a shorter way of also doing it all up to that point. Okay, great. So you have 2 talls. You see, first I have done it sorting by first by E and reverse ascending false, and then by approval rating. So you see it's true that E, the alphabetically earlier ones are appearing at the bottom, which is true. Then look at these two. Sure, they are both tall, but because it's again ascending false, you are in this situation. But you may want something different. Maybe you want it descending. So in that case, I will do this. I'll separately sort it again. Separately sort that into ascending and descending. So that's how you can keep nesting this sorting, arranging columns. This is one of the important operations. So, and I showed you how to, in fact, if you want to do by approval rating first, then you just switch that order. First by approval rating, then by E. What happened? See, approval rating was first. Then it was doing this. Any question on that? Okay, so we have learned how to deal with these sorting these data sets. Now, in order to access a column, there are several ways. df2g, it gives you that column. df2e. What about approval rating? It seems more complicated because it has a space in between. So then in that case, you might want to do you may want to do this. So you can index it. This is also called slicing. So any questions so far? Then we are going to some more interesting topic about it. Again, I'm going to go back to data frame and look at sort by values more carefully. So I want to add something into this to explain you. Okay, so here is the format for value sorting by values. Here you have to say sort values by what? Because it does not have this equal sign, that means it's a must argument. You have to. So it's a basically you have to tell sorting by what. It could be a string or an array. So now axis is by, it's the order by columns or by rows. Ascending, in place, we'll look at it. Kind, quick sort. When you have an algorithm, if the data is not already sorted, quick sort is the fastest, one of the fastest sorting algorithm. And if it is not a number position, not available, then it always puts the last. It puts in the last category because some tools want NaNs to appear at the bottom. Neil Bharwati, are you there?
Yes, yes,
Okay.
Kishore, go ahead.
Okay. Can you hear my voice clearly?
Yes, it's quite clear.
Right. Okay. So this sort has a lot of value, and sorting is one of the most important steps. So now I'm going to create a data set for you, and then we are going to play around with it, okay, and see what we can get out of it. Right? Here I have written something called students. I have put, and I deliberately. So I want to create a data frame. So this time I have chosen to create by using tuples. You see this tuple. Each tuple will be a row. First row value, for the first row values would be for the first column Jack and something. I'll call it marks, maybe age, where he lives, and so on. This is a data. I want to make a data frame out of it. That's all I'm going to do now. So the way I am going to do is just to show you, I'm rephrasing everything now, what we have learned, and then we'll go more advanced features of it. Data frame. So you can supply like this as well. There are many forms I have shown you. One as a dictionary. Now I'm showing you as a bunch of tuples. But look, in the tuples, I need to have column names that I will separately specify. And look at this function, signature. Okay, data frame. I was writing on the board that the data has to be there. You cannot create a data frame without anything, any data. So then I'm going to put columns. Let's see what happens if I don't put anything. It will probably call you 1, 2, 3. It will just name it itself. Oh, data frame is not defined. What do you think is the error? It lives in Panda. All right, so you see, it named the columns 0, 1, 2, 3. It is such a boring name, right? It's not so great. I would like it to be columns is name. I'll call it next is just called marks. City. I'll call it city, and then I'll call it age. That's it. Here I'm missing out this, right? So let's see what we get. Here, I'm able to create this data set now. This is very nice. I'm able to create a name, but what about this as well, index? I'm tired of only calling 0, 1, 2, 3, 4, 5. Can I have a name? Index, let's put it. A, let's call it. B. Oh, maybe, yeah, it could be even the names you could use in many cases because you have to refer to them. Or maybe pen number. D, E. I don't know, Z, X, Y, Z. I just will make different X, Y, Z. Aha. So I got something out of it. So I got these interesting table now. The column names are there. Also, every row has a name. That is very nice. Now, I would like to sort the values by name, say. DF I'm going to show you something interesting here. What do I say? Okay, sort values by equal to name. Great, name. Let's print again. DF ST only. See here, it did sort it by name, but again back to where it was before. But I really sometimes need to sort in place. I don't want to keep kind of sorting the same thing. Oh, by the way, you can, if you do not like this way of default way of printing, you can also say that, you know, DF ST. It will, Python will print its own way. That's another way of printing. DF ST, sorry, this is it prints it in this way. It's up to you how you like it to print it. Okay, great.
Shodi,
Yes, go ahead.
is there any unique constraint on this index? I mean, in column names, it was not there. We could
Right.
name a column.
That is a good question, and let's try. If it treats it as like a, I would not use it, but let's try anyway. Well, it seems to have no constraint in that way. So, but then it will retrieve. See, I did z repeated. So it does not.
But again, this is very bad, right? Like, I don't know.
I consider it is bad.
Yeah.
You should not allow. I mean, because the ambiguity is the worst thing you can have in computers.
Exactly. And when we are playing with data, then this is very much should be avoided.
Yes, it should be avoided. Yes. And that's one of the reasons when I write code, I always sort it so that the order is fixed and unique. Oh, okay.
So, is there a way that we can put a unique constraint on this?
Yes. You can you? Is there a way if you could enforce this? Yes. First of all, how do you enforce it? Is there any way? Let's think about it, right? So, Python 3 has an interesting concept called sets, and you should use it. I will tell you two ways, because we are, let's digress it for a minute and let's go for it in a thing way. For a in, this is how you do it. This is a common trick, you should know about it. I'm making sure that they are a duplicate, okay? So what you do if you are writing Python code, you call it say D, it's a make it a dictionary, right? And then this is the old-fashioned way, and I'll tell you the new-fashioned way. This is going to be for, oh no, D, A, whatever, you can call it 1, 2, doesn't matter, right? Great. Now I want the elements. D, I want to call it keys. Of course, so I'm directly putting the array. So you see, it gave you only one. Although there was a repeat, it eliminated because the dictionary overrides it. But is that the right way? You know, but I think there is a better way to do set operations in Python. So, and then that is something you should use it now. Set. So let's look at a set in Python. It is so whenever you create these arrays now. Let's see if it's I take the same array and a new object called S1 set. I am sure that most of the people here know set, but I will quickly repeat it for the sake of completeness. Okay. And it should be in 1 minute. A set is a list of elements, and this is how you write a symbol, give it a symbol, and within a parenthesis, you can list them out, A, B, C, D, E. And even if you have, and it does not have duplicate, does not have duplicate. Okay. And the possibilities of all the sets is called universal set. In this case, it will be lowercase alphabet, say. Lowercase alphabet. So universal set, there is another set that encompasses this A, B, C, D up to Z, right? And the fact that this always is included has elements that are already in the universal set. This is a symbol. S is a subset of the universal set. That's all I'm going to say. So set by definition, there is nothing called repeat. Everything happens once. Also, if you have another set called S1 and S2, you have EF, S1 intersection, EF say A, and set has no order. It has no meaning of order. S1 and S2 means the ones that are common in both. We know A and E are common, F is not there. So this is a new set, A and E. If you put union, that's like all the elements that are in any one of them. So it will be A, B, C, D, E, F, everything. That's all. Unless you have question. If you have a question, feel free to ask, but I'm going to show you operations on Python, how to do in Python these things, which is very important and useful. So let's see now. Exactly that example I'm going to do. The first one has A, B, C, D, E. The second one has A, E, F, because it has no meaning of ordering, that is S2. So let me show you how to use that. And it will be, it is available only in some Pythons, Python 3. That's why you should switch to Python 3. Set, let's give it an array. Set. And it is very boring to keep writing them again and again. For now, let's see. I'll copy and paste this array. Right? Okay. Set is not defined apparently here. Python 3. So that means usually if you do not have a set as a built-in function, some Pythons may not have it, and you may have to, you know, import it, call a library called sets, right? So then you may have to do import. That's where it might be. Oh.
I think it will be small letter, the set capital.
Oh yeah, it could be. Yes, you're right. Sorry, yeah, typo. Yeah, that yes. Thank you. Yes. So we have to import that and this S1. Let's see. See, this duplicate is gone. Let's use our favorite one, right? A, B, C, D, E, and then we can do the example. I'll put 2 E's here. Doesn't matter, it got eliminated. Then S2 is equal to A, F, E, I think. A, E, F, doesn't matter the order. And even if you have a repeat of many F's, doesn't matter. Set, and then I'm going to put set set 1, set 2. What about, you know, intersection? Can I do intersection actually? Sets are, so, and then also we ask, is it a subset? What is the difference? And that is very important. Let's see. Intersect, I'm going to look at intersection, or let's see, union. S1 intersection S2. See, it gave you the elements that are in both. E is in both and A is in both. What about this? It's the same. Set intersection is it's commutative. It doesn't matter who is intersecting with them. Concept is the same. You'll get the same thing. Same thing. Now let's think about union. Union should go ahead.
Kishori,
Yes.
it's in one single operation. Can we do multiple operation at the same one, at the same line?
Yes, that is a very good question, right? And that brings us to something that I was told. Yes. So let me share my, stop sharing. And there is an important thing to learn. Not only just sets, it's about actually programming languages in general, I noticed. So I had a data frame, think about it. And I should ask, when I see a variable, I should ask, what is this? Usually in Python, it's an object, okay? What can it do? It's a type data frame, so it has a function called sort values. Whatever I put, do not worry. So then I should ask, what is it become? What happens is that it silently returns another data frame with the sorted value. It's a new data frame. I can even assign it in F1. So it has given to life a new data frame after the sorting. So that means if this is a data frame, so that's why you have to ask what does it return? Because it's a data frame, I can again call on him df1 sort values with something else. Sort values. Well, think about it. I could do this return the data frame. That's why I could do this. I know that. But think about it. Look at this. Because it returns a data frame, I could do might as well nest it one on top of another. Sort values. This is a data frame. I could think about some imaginary parenthesis. I can do dot because this is the same as df1, right? This is essentially, except I choose not to hold it in a variable. I can do dot sort values. So I could continue doing it. Now let's go back to set. You have to ask, S is a set. S2 is a set. I know union is a binary operation. It can be extended, but at the end of the day, union has a meaning. It is the set, it's also a set whose elements are in any one of them. So it's again, think of it like as if it's returning a new set. Call it S3. Now S1 intersection. What happens? It's also a new set, except it has the elements that are in both. Well, if this is a set, so suppose I had another new set called S, I don't know, 0. I could easily union with it because it's absolutely fine to union two sets because it's a set. And how did I get this? Well, this is essentially returned by this. Well, I call it S3. There is nothing wrong doing this intersection. So this is essentially this operation. So let's think about a big bracket, S1, S2, this, S0. So then if you were to write in that syntax, this is how you should think. S1, okay, S1, union, great, S1 dot union, S2, right? I got this part. Then I want to union with it again. Again, you put a dot, union, S0. You see? So you can keep on nesting like this. Did it answer your question, Neil?
Yes, yes.
Yeah, so whatever you get and you ask yourself, what is this? And what can I do with it? I did this union, this is my union. What is it? Well, it returns me a set. Well, if I want to do another union, what should I put? Dot immediately, because I can call that union function on it. So essentially sets have a built-in function that, hey, I'm willing to union with another set or intersect. So you are essentially calling this function that belongs to this set and that takes in this one and returns a new set again, which you can again keep doing it. So let's do that as an example. Share application. Okay, great. Right, let's do that. So I am going to do S0 now. S0 is a new set too. S0 is a set. I say it has only F. No, A. Yeah, A. Right. So there you go. I should print it out. A. So what happens if I do intersection of all of them? I should get A because A is in all of them. Let's do that. S1 intersection with S2. I know I get AE, then again I am going to do right away intersection with S0. A, right? It's A. I could even union it. Doesn't matter, union intersection. But let's say S0 instead of A, it has F, because it should not. So let's see what happens. In this case, up to this point, what do we have? We have AE, and I'm doing intersection with F, so it should be nothing. Empty set, nothing. If you do union, then you will have A and F, A, E, F. And again, this order has no meaning. You can, set has no meaning. You could as well write F, A, E, doesn't matter. E, A, F, doesn't matter. Any questions on this? Just so that we know what we are doing. Okay. So we were in the world of intersection. That is great. So I showed you how to make individual. Okay. This is something we deviated because I wanted to tell you how to create unique. This is how you create unique. Just put it in a set and take the values in a set, and you will get the, that will be intersection. Now you can put the settings. This is how you make it unique. So far so good. So we have learned how to sort it by values. But again, you see that after you sort, you get some values, but it comes back to again. So you add columns, you did sort by name. That is great. Sort by name did not work, you see. It did not work because what happened is that although you did sort by name, it returned a new variable, which you did not capture, and you are printing the same old one here. That's why you had no meaning here. If you wanted it to show up, you have to store it in a new variable, which has it in the sorted form. This one. There you see. So that's why this is the original one. And this is the new I have created. But then, do I always have to keep creating a new variable every time I do an operation? You don't have to. Look at this. There is an argument called in place. If you do in place, it will be sorted right there and it will retain there. Let me do it for you here. Let's go back and show you an example. Let me do the same example again. No, what am I doing? Oh. Okay. Okay, great. So I wanted to show you, it's called, well, let's do it in place sorting. So that's what we are going to do. And then I'm going to do insert cell below. Okay. And this time you'll see that it will actually sort it forever in it. In and see, it really sorted. I sorted it in place and it did. Unlike here, I sorted it, it didn't work at all. I did not see the results because here I had to in fact capture the result and show you. Where did I do that? I had to capture a result, and here you have to do this. I was doing this. I'm going to show you the example. DF ST1. Here I store it. That you'd see. sorted. So that's the idea, or let's do it by city. It doesn't matter. City, Delhi showed up first. So that is to permanently change it in that variable itself and store it. So that is the idea. So now I'm going to, you can also sort it by values in another insert below. As before, you could do in place, and you can also put by first by city and then by name, or any order you want. But that's the order it respects. See, and because it's in place, you can just type it in C. Sure, first by city and by name, Delhi, Delhi, city, and then you do by name. In fact, I should have changed this name somewhat instead of repeat. That looks better. Right here, you see, Delhi, Gayatri came first. Ritis are second. So that's the idea. So then, what next? So well, I showed you in place. Similarly, you can do it by any other tuple. You can even add, I don't know, in place. Delhi, yeah. So that's good. So there is a name and is. Okay. So any other question here? Now I'm going to show you something more cool operation, actually. Much more interesting than this boring thing. All right. So somebody told you that, you know what? Let us see. Okay. So marks, I'm going to add into 2 more columns. I'm going to add how to insert a new column here. Right? You got marks. Can I add another new column? Let's call it df, say data science marks or math is equal to. Can I do this now? I can do Numpy array. I don't know, 40, 60, 30, 30, 20, and 50. Can I do something like this? What happens? df math. So now the question is that, okay, that is not because of that is because of my typing skills lack of. So what happens? So I decided to add 1 more column. This is how you can insert new columns. Let me show you now. So you have got these math marks. I can add another one. I have a reason for adding. I'll show you. Math, computer science, computers, programming. 43, 32, 30, 31, 40, 5. So you got programming. So what I think that I really would like to filter it by candidates who have an first, let's see if we can create a new one, aggregate one, right? Aggregate, sum of both. Yeah. This is like your Excel aggregate, AGGRE, aggregate is equal to df math dfst students, add them up. Let's first just print it if we can. So this is the added marks, right? So I can add it like Excel formula, column, every row. I can maybe even store it somewhere. So, and maybe I can even sort it by it, who knows, right? So let's see. I can store it, add as a new value as well. I call it aggregate. Okay, I'm going to write aggregate. Let's print it. Did it change anything? So aggregate you got here. So you're able to add a new thing. So can I sort it by aggregate then? But what about average? Average is also important, but we'll get there now. So this now, I want to sort it. Sort by value.
Hey, just one quick thing here.
Yes. Go ahead.
Why aggregate came in output 198?
Oh, that's interesting. Aggregate came out as you mean aggregate came out here, right? Are you asking? Oh, in 198. So aggregate. I see. That is a good question. So in this Jupyter notebook, the order of the cells do not reflect the order of the program. It is the order that you execute the cells that matter. So what I did, I had already executed it, but this DS already has aggregate loaded. So I again printed it here. That's why. Did it explain?
No. Sorry.
Okay, okay,
See, I think it's top down, top bottom approach, right? From top to bottom approach.
This
Sequential.
does not. This has no top to bottom approach. It is the order that I decide to select, execute the cell. For example, I'll tell you here. Here.
Okay, so you executed first 200, then 198.
Yes, that's by mistake by playing around. Yes.
Okay, no problem. Thanks. Got
Exactly.
you.
Yes. So now here you see we are stuck with DST forever. Now aggregate forever. So yes, that's the. So now I want to sort it by this, right? And then will it do anything? Give me anything? Yes, it does give me aggregate in the ascending order, which is the default. Okay, so that is very useful. So I can sort that means by aggregate. Could I have not calculated average? Maybe, like in many engineering colleges, they take the average. Okay, so that's the average. So I could do actually average too, like this here, which is great. I'm able to do, sort it by some value. So perhaps I could even do better actually. Why sort it and all? Maybe the length of the city that you live in also has an impact somehow. Mumbai, somehow I give less weight to the name of the city that you are in for some reason. I do not know why, but then I can do this kind of thing. Because it's a string, how do I compute the length of the string? len length, then dst, I take the whole thing, right? Aggregate st. So that means length can go through one element at a time. This length function in the city. There you go. So it also computes the length of the name of the city you are in. Of course, this average, I don't know what it means, why I'm even calculating that kind of style, but it's something you can say. Aggregate is now much more bigger composite. So somebody asked that, well, you calculate like this, and I want only those guys sorted by this aggregate. So then you can do this sorted by aggregate. Then I will show you filter also. So what else is there? I can show you sorted index. Right. Okay. So this is what I wanted to show you, that you can do these calculations on the fly without but in order to do these things, I really let me think about it. So sort index false. I want to give the location in the ascending order. Okay, yes. So think about this. Do I really have to calculate this aggregate and all? I mean, is it really worth it? Why do I have to do all these things? I really don't want it. I want to drop it. df drop. One df Can I do that? Drop this a column? Maybe I can. AGGRE gate drop. Oh, it's not dropping now. Let's see, I'm trying to drop this value completely. DFST. Oh. Okay.
Sorry, what is this one for?
I need to do in one place. I need to keep it in one place. I mean, in place, that kind of thing. So df sp1. So that's what I needed to do. So that one column. Now, what about dropping it in place? It created a new one. See, it still has it, but it's just a new variable. What about if I do in place? Will it drop in both? So it dropped forever. df stl, it dropped right from the table. You don't have to create another data set. Any questions? Okay.
No, why that one? Aggregate one?
Oh, this has to do with column. Aggregate one. There is this axis that the column axis.
Sorry, not.
Hang on, sorry.
That's not clear actually. So if you don't give that, it won't work.
So yeah, so it's a axis column. That means the whole column. Otherwise, it will be 0. You have to put the axis.
Okay.
So
Yeah.
one represent.
Actually,
Here's
you
the column,
probably
right?
even remove it. Sorry, you can probably even remove it. Or no. Oh yeah, see, it did not find the axis. Because axis 1 is all the columns. You have to tell it that drop the column. Axis 0. Sorry.
So here axis represent its column or row, right?
Axis 0 means row. Axis 1 means column wise.
Okay. Okay.
No, so if you want to do if either you can remove a row or a column. So axis 1 means it's column wise, the whole column, take it out.
Okay.
Yeah. So again, I'm executing it.
You have entered in the wrong column. 217. You remove that axis one.
Oh, okay. Yes.
It's sorting.
Yeah. Yeah, so X is 1, yeah. So aggregate. Oh, I see. I'm sorry. Yes, I sorted, right? Sorted by this. Yes. Sort values in place. I want to call it.
Typo there.
Yeah, type. Yes, thank you. So now you want to drop it by 1. So you can do this is df1. Okay, so let's see now. Okay, no, this is unnecessary. Aggregate, we need to make sure. Drop this. I see. This is, I want to drop it right there. So I dropped it. So what about, is it possible to drop something else? Like, let's see. Here, I'm going to drop in place Y, maybe, I don't know, X, 0. Oops. DF, ST, I need to print it. Oh, too late, it's already deleted. Because I executed it, deleted already. Okay, you see X is gone. So if I want to delete C, say for example, so I have to again do it by in place 0. But 0 means row wise, 1 means the whole column wise. That's how you can remember. See, drop, which one do you want to remove? Z maybe? Z and 0. X is 0, right? Because it's row wise is X is 0. Column wise is vertically. So in place, and then it's df. There. Kamal, is it clear how axis works? Whether you want to remove the whole row or hold the column?
Got you. But that is a mandatory attribute which you have to give when you are dropping
Yes.
it, right?
Yeah, because otherwise it cannot figure out, right?
Correct.
Yes.
Got you. Thanks.
Yeah. So now.
Okay, sorry, one
Yes.
question.
Yes.
Like when adding new columns or dropping columns, can we do it at once? Like you added 2 columns, maths and programming, so in different lines.
Oh, you mean want to add different, operate on different columns?
So add multiple columns, like create new columns.
Yes, you can do that. Keep on creating new columns programmatically, right?
Yes.
Yeah, with code, you mean, like, yeah. So let's see if we can do that. Let's see if we can do that. So what we will do, we will create a bunch of columns, A1 through A10 or A5 automatically. For I in range 5 up to 0 to 5. Let's say 0, it's easier. Call name, right? Column name, like call it A plus a string. Make the I string. This is my column name. And I know that each column has 4 values for now, somehow. So then values, vals. I call it I. The first column will be all 1, 2, 3, 4 like that, or maybe range I from I to 4. So it has 4 values. So the first column A1 will be like 0, 1, 2, 3. The second one would be 0, 1, 2, 3. Second one would be 1, 2, 3, 4. The third one would be 2, 3, 4, 5, so on. So values, and then df st column name, see, column name is equal to np array, right? Numpy array, give him the values. And then print dst. Look at this. I was able to create on the fly. Nimisha, did it explain your question? Neil, can you hear me?
Yes, I can hear you clear. Yeah.
Okay. Is it the question Nimisha asked? I forgot. It was not very clear. I mean,
Yeah,
the
she
sound
was. Yeah, she was looking forward at how can we add multiple rows and columns in the same code or something. I mean, if I can understand her correctly. That's the Nimisha. Is that the question that you asked?
Oh,
Seems like her connection is lost somehow.
okay.
Yeah. Okay. I probably should come back. And you asked that questions to her again, probably.
Yes. So this is how you can guys, do you have any questions? People?
Yeah, I think she has joined back. Probably we can ask that question to her. Okay.
Okay.
Nimisha, can you hear us?
Sorry, I got it.
Oh, no
Yeah,
problem.
no.
So,
Yeah, so yeah, sorry, Kishore, go
Nimisha,
on.
so this is what I was doing as an example. So I took a for loop and it goes from 0, 1, 2, 3, 4. That's the value of I. And I created an artificial column name A plus 0, 0, A0, A1, A2, A3, A4 in every iteration. And for values, I always calculate the range from I through 4 up to 4. If I is the first one, it will be like 0, 1 to 3. Second one would be, because I is 1, 1, 2, 3, 4, 5, it keeps on increasing. And then I created this column name and the values for the column, and I put it inside the data frame against that column name in a NumPy. And then I printed it, so it automatically added several columns. Is this something you are asking? If we could do it automatically?
Yes. I mean, not exactly. My question was like, you were adding it one by one, different columns, right? Like math and programming. So that only I wanted to know, like, can it be done one at a time? So this is how we'll do that.
I see. So if you want to add a whole bunch of it, so the way you do is, this example, remember? Here, all the columns and rows were added at one shot. I stored a value somewhere in an array of tuples, and I directly create like this at one shot. But if you want to add something based on intermediate calculations, then you have to either calculate upfront and create this structure of an array of tuples, or you have to add it as you calculate this aggregate and all, like I was doing. Yeah, if I did not answer, send me a question. I'll send me an email, send us an email, and I'll answer, prepare something.
So maybe she's questioning, like, can we update our data from a file? Say, for example, if I have an Excel
Yes,
file where
absolutely.
Maybe that is a question.
That you have been doing for a while. Look at this.
Yeah, that's what.
I'm uploading on the fly from the internet, actually. Reading a CSV file and creating this. Not only you can read it from your local machine, I'm retrieving it from this website actually. And Panda can pull that as long as you tell what format it is. Kamal, did it seem to answer?
No, I'm aware of it. Yeah, I got that. I thought
Okay, yeah.
she has the query on the similar lines.
I see. Okay. So that's that's the idea. Yeah.
Yeah, I have a question. Here
Sure,
we
go
have used dfst column name is equal to np.array of values. Can we directly use values here?
Yes, you could. Let's go and do this time a few more columns. A is already done, right? Let's use B. Few more columns, B5. Can we do that? My It's absolutely, you should be able to do it. Oops. So there is a syntax error. There.
Okay.
Yeah, so you can do that. But I like to do Numpy array because, you know, it's a cool array. You can ask it a lot of questions, how many elements you have. You can represent not a number, all these things, which are really useful. So try to use Numpy array if possible. It's a good habit because you can get more advantage out of it. For example, if you needed to find out what is the column name, what is the what is the length, shape, you can quickly get it without doing messy calculation yourselves.
Okay. Okay. Thank you.
Yes. So in theory, we should be able to drop them too with code. At least let's get the drop the ones in A maybe. Column name, how would you do that? Drop. Yeah, so also in place. There, you're gone.
Okay. Also, we can drop something with a filter like if name is equal to.
Yes,
Something.
absolutely. Yes, we will keep getting there. Yes, absolutely. So in that case, so you have to learn, we have to view the concept of index. What does an index mean here? We can have a name, we can have things, but what does what does it mean to have an index? And that's what is important for us now. Let's look at the index. So let me quickly go for an df, right? Df st. Can I do something like this? Df dot maybe math score, or no, programming must be more than 29. DFST. So I'll tell you what it means. First, just believe me, okay? Programming had to be more than 29. What about 30? That means I will eliminate the first. Gone, right? So you are able to filter actually. And it says only the ones that are in programming, and this is how you do it. What if you want an AND, right? Again, same logic, see? This you applied on a data frame. What do you get back? Data frame. Ask him another question. Data frame, okay, another question you can ask, that in the original data frame, of course, age should be more than 20. Yeah. This, for now, leave it. I have not tried it. This warning, I don't like this. It will be reindexed. I don't like to see. There is nothing wrong, but it's just that like. So, okay. So what essentially is this? Why did it think about it? Why is it just because I put in square bracket this and it started filtering the rows? What do you think? Okay, let me tell you another thing here. Instead of programming, I can say that I know that anything that is more than 30 is BCA, right? BCA. Could I have said that, get me those values of only BCA? B, C, A, those rows? No, it does not. Right? BCA, let's see. here BC. Okay, so I know why it does not, but I'm just trying something to see if I can do something funny. Okay, I cannot do that anything funny. Can I do colon? Okay, I cannot do anyway. Anyhow, so the trick is here. I want to show you. DF is, or programming, it creates a bunch of true false conditions essentially when you put a condition like that. PRO, GRA.
df underscore st.
Yes, sorry, thank you. So you see, it essentially created for each row a condition. False first line is, true, right? That's all it essentially created, nothing else. And this was indexed with the original DFST. So let's see if I can put true, false, true, true. What do I get in the original DFST? This is something I'm trying to. So this is what I get, and then I say the first one is a true or false, true, true. Did it work? It works. So what does it mean? That means as long as you can give for every row a value true, false, it will exactly match this array. Oh, false. What does it mean? Oh, the first guy, why? He's false. Forget him. I will not pick him. Second guy, true. I'll take the 2. True. I'm going to take him. Take him. So this is the idea. So how do you create this array of indices? By directly providing him what produces this array. Let me go there again. This is important topic I'm doing. This is for this logical statement creates that true, false, true, false. In this case, all true. So all will be selected. Any questions, guys? This I want to revisit again. Keep talking about it a little bit more.
Depending on these conditions, we can even drop the rows.
Yes, you can drop the rows. Yes. Of course, you have to create a new. This is more of a filter. It will create a new data frame with those. But in order to drop in place, you have to do the other way. Drop with access 0. Because this is just a filter, right? Even though it's a filter you see, like for example, df st, I'm going to get this, right? No, I'm going to, programming is, I need at least 30. I dropped it, right? So now you would expect that if I do ds, and I want to do say city is equal to Delhi, df how do I do that? I'm trying to see. Oh, city is Delhi, right? Great. It doesn't like my typo. So see, according to the previous one, Delhi was out of the scene. First Delhi was gone, but again it jumped back, you see. But if you had dropped it permanently, then it would not show up again. Because we did not drop it. It's still in the data. It's just that you chose to filter it this way twice. But let's look at the other way. What I'm going to do, df st, I have everything, and I'm going to delete the y, which is going to be dropped anyway, which is what I want to do, which I was filtering out before. Drop y axis 0.
Kishori, instead of y, can we use a filter condition here?
If you use a filter, no, somehow you have to get to y. Well, with logic and all, you have somehow to get to the y, but you have to, at the end, you have to get here a value y somehow. It may be by index, index name, but you have to directly say which row you want to delete exactly. Filter will only superficially hide it for you, but it will not delete it. But here I'm trying to delete it in place and get rid of it. So here you see in place, true, it will be gone. Y will, you'll never find Y again, right? So now if I do df st, you don't find that Y. But let's do the city filtering now. Now you'll see that Delhi, the first one, is permanently gone. You will not, the result is that, look at the thing. In this case, it gave you two cities conditions, Delhi. Here only one, because the first one, because in the first case, Delhi was just filtered out just to hide it, whatever it returns. It does not delete it from it. That's why when you did Delhi, again the second time condition, it completely, it did not think, it refers to the original data, 231. This is just to show you because you filtered it out. Because you have both of them are not deleted because it satisfies the condition, it printed 2. But again, we start from here. We drop Y in place where that was one of the Delhis, and it's gone forever. You will not get it back. So we are left with this. So when you apply this filter, you exactly get one line. Nimisa, did it explain your doubt?
Yes.
Okay,
So
yeah.
I mean, just to confirm, we have to enter the exact index number which we have, which row we need to delete. We cannot use a filter conditions here.
Yes, exactly. But if you want to drop several rows, you can of course create an array that will have the indices, and you can somehow back it out from the filter conditions that I will show you, and then you can get there. But that's not the, that's a convoluted way, a little.
Okay.
Yeah. So what about if I just apply a condition without thinking? Like, let's say this, I'm like, I don't care, I want only numbers. I don't know what your values are. I don't care, I just don't like anything less than 1. I'm sorry, not less than 5 or 4. Wherever, I don't, which, you see, any value that you wanted to get rid of, you give this, and it is not a number, because it cannot, it looked at, when you do this, it checks every cell individually. If the cell value, if it can compare with a number, and if it does not satisfy, it will become false, and it will give not a number. Because by definition, your data frame is, these are supposed to be numbers. Now you don't even want these numbers. I cannot delete the whole row. That's because that one was an, here, this creates an array because you are doing dot city. Here, DS greater than 4. You are doing it in the entire data frame, not just one column. So what does it mean? What kind of a true false is that? You'll see that it's slightly different. That's what you get for that. DS T4, right? This is 4, bigger than 4, 4, 4, 4, 4. You see false. And this is false, right? These are true. False because, no, you should not look at it. This is just the filtered one. Look at this. So what about this? All of them are greater than 4, right? So that means these guys are not compared. The strings are not compared. And what about if I make it 5? See, the strings are not compared. Only numbers are compared. These are, so it produces a bunch of true false statements, essentially true false. And if you feed this, this is itself a data frame, you would see. So essentially you are sending a data frame of booleans, and it is operating point wise. I mean, one, you see, it's a data frame. Then I want to know what, if it is a data frame, it's strange, right? I mean, it's strange, it's a data frame. We are used. Then what about the types, D types? Are they all Boolean? See, all of them are Boolean. Any questions on that? I know it should be a little bit funny, but
Kishore,
yes.
can we put a multiple condition and like the way we put it?
Oh yeah,
Okay.
I see. Shall we try a logical statement? Let us do something equal to 4 and df st. Well, Python should be, Python is more of a and kind of statement. You have to write it out, logical statements. But first, let's see what does it do. You see, other than Delhi, everything is an and. Now let's try df st and. So, truth value of data frame is ambiguous, so it doesn't look like it can take data frame conditionals. But we can apply one after another though. One after another we can apply. This you can do. Then the rest are non-nan, not a number. So you can do nested in this kind of way. So now,
here it is not taking the condition, this one, that
say that again.
if my underscore st is greater than 5.
Oh, you want me to remove it?
You said we can do it nested, but it is only taking the last condition, not the previous one.
Oh yeah, it's essentially it will apply one after another, right? So, oh, hang on. No, right. So this part, let's see. I'll show you here. Let's copy it. So let's take this, call it df, I don't know, A, say dfa. And dfa, let's print it out. So dfa, you got anything bigger than 5, you kept it, anything else is, if it is a number, gone. Now let's do the other one. Now I'm going to apply in dfa another condition. If it's equal to, I'm not going to do it on dfa. ds, still the original guy I'm going to give it to. Let's see what happens. They are of similar condition, they are of similar dimension, right? So I don't have to be worried about. But let's see, it's strings. So you see, that is again that. So this is exactly what I was saying, that you can actually, even if you put together, you'll get the same result. Let's see. Oh no, not this one. Edit, delete cells. I want to put below this to show you an example. So here, let's do it at one shot, right? So df at one shot, df st, df st bigger than 5, and immediately, because it's again a data frame type, I can again apply the square bracket. I'm going to do it right away. See, you got the same result. Whether you did one step at a time, right, you also arrive at the same thing here. So you can immediately do it instead of creating an intermediate one. So any other questions, guys? So we are, go ahead.
Here we can't have both the conditions, right? If it should be greater than 5 and
yes,
it is
it has
Delhi.
become and, yes. Yeah. And so that is the idea. Any other questions? So we are coming towards the end of the class. We'll revisit a little bit of it again. and then also do NumPy array. NumPys actually, not NumPy array, NumPys in more detail. But let's ask questions, anything? How to use it, where to use it? So what I'm going to do, I'm going to mail you this Jupyter notebook and you should play with it.
Yes, that would be a good option. Yeah.
Yes, please play with it. And again, you should play with it. Later, we are thinking of setting up a server because some people might feel lazy to install. We might provide a server where they can play with it. But we are thinking about it after, because maybe some people thought, hey, I will do it later, that kind of procrastinating. And then, yeah, so that's where we are at. Any other question?
Thank you, Shuri. Sort of this side.
Yes.
Yeah, it will be great if you provide a list of common functionality usually used in Pandas.
So yes, so we are providing actually, we'll provide some now with this and we'll cover the rest later, and I'll also provide those lists. Yeah, okay. I'll provide those lists and some documentation.
Thank you.
Yeah. Any other question? Well, thank you guys, and I'll see you next time, and I'll send you this information and the Jupyter notebook.
Okay. Thank you, Kishore.
Thank
Thank
you.
you. Thank you.
You're
Bye.
welcome. Bye.
Thank you, Kishore.
You're welcome.
Kishore, not related. I have a question not related to this class. Just that, can we have sessions on Sunday as well? I mean, like weekends, Saturdays, it's just a bit like small sessions we have.
Right.
Even on Sunday.
Let us see what we can do. But also, by the way, if you have any questions, send me questions. Then I can send you recorded material as well. But yeah.
Okay.
Yeah, we'll.
Thank you.
Okay. Thank you, Kishore.
Thank you.
Bye-bye.
Bye-bye, yeah.
Thank you.
But yeah, thank you.